So we want to evaluate the definite integral from -1 to 2, from -1 to -2 of 16 minus x to the third over x to the third dx. Now at first this might seem daunting. I have this rational expression. I have x's in the numerators and x's in the denominators, but we just have to remember, we just have to do some algebraic manipulation, and this is going to seem a lot more tractable. This is the same thing as the definite integral from -1 to -2 of 16 over x to the third minus x to the third over x to the third minus x to the third over x to the third dx. And now what is that going to be equal to? That is going to be equal to the definite integral from -1 to -2 of, I could write this first term right over here. Let me do this in a different color. I could write this as 16x to the -3, x to the -3. And this second one, we have minus x to the third over x to the third. Well, x to the third is just over x to the third over x to the third is just going to be equal to 1. So this is going to be minus 1 dx. So dx. And so what is this going to be equal to? Well, let's take the antiderivative of each of these parts, and then we're going to have to evaluate them at the different bounds. So let's see. The antiderivative of 16x to the -3, we're just going to do the power rule for derivatives in reverse. You could view this as the power rule of integration or power rule of taking the antiderivative, where what you do is you're going to increase our exponent by 1. So you're going to go from -3 to -2. And then you're going to divide by that amount, by -2. So it's going to be 16 divided by -2 times x to the -2. All I did is I increased the exponent and I divided by that amount. So that's the antiderivative here. And 16 divided by -2, that is just -8. So we have -8 x to the -2. And then the antiderivative of -1, well, that's just -x. Negative x. And actually you might just know that, and hey, if I take the derivative of -x, I get -1. Or if you viewed this as -x to the 0 power, because that's what 1 is, well, it's the same thing. You increase the exponent by 1 to get x to the first power, and then you divide by 1, and so, yeah, I mean, you could view it as that right over there, but either way, you get to negative or minus x. And so now we want to evaluate that. We're going to evaluate that at the bounds and take the difference. So we're going to evaluate that at -2 and then subtract from that this evaluated at -1. And let me do those in 2 different colors just so we can see what's going on. So we're going to evaluate it at -2 and we're going to evaluate it at -1. So let's first evaluate it at -2. So this is going to be equal to, when you evaluate it at -2, it's going to be -8 times x to the -2. So -2 to the -2 power minus -2. And from that, we're going to subtract it evaluated at -1. So it's going to be -8 times -1 to the -2 power minus -1. All right, so what is this going to be? So -2 to the -2, so -2 to the -2 is equal to 1 over -2 squared, which is equal to 1/4. So this is equal to positive 1/4. But then -8 times positive 1/4 is going to be equal to -2. And then we have -2 minus -2. So that's -2 plus 2. And so this, everything I've just done in this purplish color, that is just going to be 0. And then if we look at what's going on in the orange, when we evaluated -1, let's see, -1 to the -2 power, well, that's 1 over -1 squared. Well, this is all just going to be 1. And so we're going to have -8 plus 1, which is equal to -7. So all of this evaluates to -7. But remember, we're subtracting -7. And so this is going to result, we deserve a little bit of a drum roll, this is going to be equal to positive 7. And obviously, we don't have to write that positive out front. I just wrote that just to emphasize that this is going to be a positive 7.